Boom. All right. So we're going again, and we're continuing this series of videos where we're looking at the length and the midpoint of a line segment. All right. So we would have already discussed the horizontal, vertical. We discussed two particular cases, of a diagonal. Right now I want to continue with this one, but instead of considering directly the actual physical demarcation of the measurements on the horizontal line CQ and the vertical line CR, what we could do is look at the coordinates of the points themselves. Because watch this piece of magic here now. We already figured out that this distance here was 6. Alright? But if this line is parallel to the x-axis and this is the point 18, 2, then this is the point 18, 17, 16, 15, look at there, 14, 13, and 12. So this point C is the point, right? Let me demarcate the point C now. So this point is the point C, this will be 12. And let me do the same thing for the y coordinate now. We went up 10 here, right? Remember, this is the point 12, 10. So from 0 to 10 will take us 10 here. Same 12 that we have here. So if we go down now, 10, 9, 8, 7, 6, 5, 4, 3, 2. So this is the point C, 12, 2. Alright? So this point, and then we can now measure it off here now. 5, 10, 1, 2, 12. And then we go up 2. 1, 2. That's the point there. 12, 2. So this is the point C, 12, 2, which we could clearly see by looking at the overall diagram of the right angle triangle there. What's the importance of knowing the exact coordinates of the point C? Remember, in the previous video, we determined that CQ was 6 without reference to the coordinates of C. We just looked at it from a strictly from a diagrammatic point of view, where we have the actual diagram drawn to scale. Alright? A real diagram and a real set of coordinate axes where you actually have units measured off. You could do that provided that you construct a parallel line here, parallel to the x-axis of course, and a parallel line here, parallel to the y-axis. Now, you don't absolutely have to do that once you have the coordinates of the 2 points. Yeah? So we could get the same 6 because the distance from the y-axis to this point is 12, and the distance from the y-axis to this point is 18. So the distance then between these 2 points would be this whole distance minus this distance, which would be 18 minus 12 to give it the same 6. And we do the same thing here. So the distance from the x-axis to this point here would be 10, and the distance from the x-axis to this point here would be 2. So the distance between this point and this point will be this whole distance 10 minus this distance 2, which will give you 8 out here. So in other words, what we have in fact done, same right angle triangle, but with a slight difference here now. We have the same right angle triangle, alright? Yeah? Sorry. So this is C, this is Q, and this is R. CQ is 18 minus 12, and CR is 12 minus 2. 12 minus 2. What's the importance of that? You'll see in a minute. And in case you didn't realize, we would have done the same thing here in the case of this diagonal that passes through the origin. And I'm going to use some space on this side to actually show that that's what we did. Because what you actually have here is a parallel, I'm mixing up a couple concepts in my head here now. What you actually have here is a diagonal line segment, defined by the origin O00 and the point P86. So we draw a line here. Alright? This is the origin O, 0, 0. And this is the line, this is the point P, 8, 6. Yeah? And the same thing that we just did here, we do over here. The only difference here is that because the line passes through the origin, you immediately have your horizontal, which is the x-axis itself, and you immediately have your vertical, which is the y-axis itself. Which means then that you then have, watch it now, remember that we would have seen that this was the point A, 8, 0. Alright, so let me draw. Alright. Let me draw the triangle. So, watch it. 8 minus 0. So the x coordinate 8 minus the x coordinate here is the same 8. 8 minus 0 is 8. 6 minus 0 is 6. So we in fact have now a right angle triangle where this is the point O, this is the point A, this is the point P, and this is the right angle here. This is the length 8 minus 0, and this is the length 6 minus 0. Alright? 6 minus 0 is 6. 8 minus 0 is 8. So you have 8 here and you have 6 here. You use Pythagoras theorem and you get 10 as the length. Over here, 12 minus 2 is 6. 12 minus 2 is 10. 12 minus 2? Sorry, it's 10 minus 2. Oh my word. Sorry. Again, I'll leave in the mistake there, because if you would have looked at the video to this point, you would see where I made the mistake, right? I'm not trying to hide my own mistakes. Teachers make errors, right? Sometimes you're explaining something and they make a mistake. And if we were in a live session, somebody in the class would already have piped up and say, "Sir, you make a mistake." Nothing wrong with that, right? Of course, because it's me alone just doing the recording, I don't have the luxury of having a set of live children or adults or whoever it is ready to go, and as soon as they see the mistake, they point it out. Alright? But I pick it up. So this is 10 minus 2, this is 18 minus 12. So 10 minus 2 is 8, and 18 minus 12 is 6. We have the same 8 and the same 6 to give it the same 10 on the hypotenuse when we apply Pythagoras theorem. Now, where are we going with all this? Those of you who would have seen the formula before, by now you would get some sense of where we're going, and maybe you would probably be in a position to appreciate. This would be the third video. We would have done 15 minutes 1 and 15 minutes 2. Alright, so in other words, my method of teaching is to spend a lot of time at the beginning explaining certain things, so that when it's time to memorize, and yes, in some cases cram, at least you would have as much as possible some kind of idea of what you're doing, so that now when I start to get general, you wouldn't have a problem remembering what the formula for the equation of a straight, for the length of a line segment is, because that is not one of those formulas that is on the formula sheet. Alright, so for the purposes of CSEC, the formula for straight lines would not appear on the formula sheet. So gradient of a straight line, you wouldn't get that on a formula sheet. The midpoint of a line segment, you wouldn't get that on a formula sheet. The length of a line segment, you wouldn't get that on a formula sheet. Fortunately, if you go through certain foundation principles like I have taken the time to go through here, remembering it, if you forget, let me say you forget the formula in an exam, you have some kind of ability now to kind of go back and construct something. You remember what we do in the video here, and you draw a little diagonal, and then you draw a little vertical line, horizontal line, and as you do that, things will start to come back, and then you'll be able to derive the formula even under the stress of exam conditions. Alright, so you have that ability. Now of course, as you do enough questions, what you find tends to happen is that the formula would stick, which is why I put the amount of questions that I normally put at the end of each video, so that you get the opportunity to practice and you get the opportunity to have something stick, so you don't go in the exam now. In other words, we want to reduce as much as possible the likelihood that you'll go into the exam and forget the formula, because you would have done so many of these questions before that as soon as you see it, once you recognize that I have to use the formula, I can just pull it from memory and do it. But in the unlikely event that you forget the formula, you still have some method of actually deriving it from scratch and then proceeding to execute and finish your working. So, having demonstrated certain kinds of concepts here with respect to using the difference in the respective x coordinates, 18 here minus 12 here, right? 18 minus 12 will give it this 6 here, right? 18 minus 12, because this 12, the x coordinate is along the same line as this 12 here, right? So 18 minus 12 is 6, and 10 minus 2, all right? Yeah, 10 minus 2, because this 10 is this 10 here, and then this 2 is this 2 here. So from here to here is 2, from here to here is 10, 10 minus 2. Alright? So this 2 being the same as this 2 here. Alright, you get the 10 minus the 2 here to give it 8. So now I could do this in a general sense, and we could actually derive the general formula for the length of a line segment. Before I do that, however, I want to also demonstrate the midpoint. Alright, so I'm going to use up the remaining time for this video just demonstrating the midpoint for the, we already did it for the vertical and horizontal line, so we're going to stretch the argument to the diagonal lines. Now that we have this set up here, and then in the next video we will derive the general formula for the 2, and that will be it for this particular series of videos. So let me start with the diagonal passing through the origin. Now, this is not an exact mathematical proof. Right? There is a difference between proving something mathematically. There's a difference between a proof and a demonstration. I could demonstrate something by appealing to your logic, by appealing to your common sense, by appealing to your observation. Mathematical proof, the strict, rigorous academic standard of what constitutes a mathematical proof, is a different thing, which wouldn't concern you at this level at any rate. right? I think the first place you will start the meet proofs is at the level of admats, where you might have to prove what we refer to as the trigonometric identities in trigonometry in section 2. Alright, I think that is probably the only thing that you'll have to prove in admats. Right? And then of course in form 6, where you're doing pure maths, unit 1 and unit 2, you had to prove certain things, and I am guessing as well that you'll be able to prove certain things in applied maths as well. Alright, coefficient of friction and them kind of things. But don't worry about them things. Let me deal with what we have before us now. So I will appeal to your common sense, right? Because a lot of maths is common sense. Yeah. If we have a line segment that is defined by this point and this point, in other words, you're moving all the way from here to here, it stands to reason, logic, and common sense that the midpoint you have M, N, and then we call this element of P, Q, R, S, T, U, V. Then we call this V. Then we call this the midpoint V. Just as was the case here, is halfway across the length of the line. It will be halfway across the length of the line. So in other words, whatever the distance we travel horizontally, we expect whatever the distance we travel horizontally to get from one end of the line segment to the other end, we expect to travel half of that distance to get to the midpoint. So if we move from 0 to 8, 0, 0, I put the actual coordinates now, 0, 0 to 8, 0, then we expect that the x movement for the midpoint, x coordinate would be 1, 2, 3, 4. Alright? So we expect that this would be the x component for the midpoint, which is half of the 8 for the whole line segment. And we expect the same thing to happen vertically. So seeing that we move from 0 here to 6 here, alright, there's the point 0, 6, then we expect that the midpoint will be half of this entire movement, which will be 1, 2, 3, which will be this here. So that this will be 3, this will be 4. So that this will be the point V, 4, 3. Alright? Now you see it making sense, because this is 0, 0, this is 8, 6. So you expect the midpoint to be half of 8, which is 4, and half of 6, which is 3. But we now have to deal with the situation where we don't have the line segment passing through the origin. We had to deal now with the 2 points outside the origin. So in the same way that we move from, let me move from left to right now. It doesn't really matter, but just to maintain the convention in this case. In the same way that we move from 12 to 18, which is a movement of 6 units, to get from this end to this end, we expect that at the midpoint, we'll be moving 1, 2, 3. Right? It's not exactly drawn to scale, but, right? So this would be 15, right? Which makes sense. 12 to 15 is 3, 15 to 18 is 3. 12 to 18 is the entire distance from this point to this point. And we expect the same thing to happen on this line. So in the same way that we move from 2 to 10, which will give us our movement of 8, then we expect to move 1, 2, 3, 4. This will be 6. And then we come across here, alright, as a midpoint. So 1, 2, 3, 4, and then 1, 2, 3, 4. So this will be the point 15, comma, and this would be the point 2, 6, 15, 6. Alright? Now, watch it. 12 to 15 is 3, 15 to 18 is 3. Alright? 2 to 6 is 4, 6 to 10 is also 4. So from a purely common sense perspective, we get a sense of how to find the midpoint of any line segment. Alright? What I'm going to do now is just develop a general formula for the midpoint of our line segment and the length of a line segment using all that we discussed here, and I'll do that in the very next video.